Okay, class, today we're going to talk about projectile motion. And projectile motion is a pair of parametric equations where we have the x with the cosine equation and the y with the sine equation. And the equations will be like this, and we'll just plug in the different unknowns and knowns. So your v0 is your initial velocity, or your velocity at time 0. T is going to be your given time. Theta is going to be the initial angle in which you throw the ball or the ball is projected. Negative 16t squared has to do with gravity. The v0 is going to be the initial velocity. Then you have sine of theta, again, your same initial angle. T is your time, and S0 would be your initial height of your object. So your object at time t equals 0. So for this example, we have a ball that's hit into the air at initial velocity of 92 feet per second, so that's our v0, at an angle of 15 degrees, so that's our theta, and an initial height of 3 feet, so our S0 is going to be 3, because that's our S0. Determine the set of parametric equations, so we're just going to write x equals, we're going to plug in v0, and our initial velocity is 92 cosine of theta, which is 15 degrees, and then we're going to multiply all this by t. And then our y equation is negative 16t squared, and it's always going to be that because, well, on Earth, that always has to do with our gravity, plus v0, our initial, is 92 sine of theta, our initial angle 15 degrees, times t, plus s0, and our initial height was 3. Oops, 3. So this is our set of parametric equations. So what we're going to do next is we're going to take our pair of parametric equations and we're going to graph the equations on our calculator and write down the window that we're going to use. Okay, so we're going to talk about the window and then we're going to move over to the calculator. So for the window, we're going to have our T min, T max, T step, and then X min, X max, X scale, Y min, Y max, and y scale. We're going to have our window, so we're going to have our 3 values for our t, we're going to have our 3 values for our x, and we're going to have our 3 values for the y. T is going to have to do with time. When we throw the ball, t is going to be 0, or we hit the ball, time t equals 0, and just think about this logically. How long is a ball in the air? I don't know, maybe 5 seconds would be appropriate, maybe less. And our t-step, we just want to do a small number so the calculator does it curvy and not straight as we've seen in the past. So I'm going to pick a value of 0.1, just something small. X, well, I'm going to start with 0 because I'm going to look at the ball going. It starts from an initial height of 3 and it's going to go, and then it's going to hit the ground. Okay, so it's going to go from 0 to, I don't know how far the ball goes and how high the ball goes for the x and the y's. I don't know how far balls go when you hit them, but maybe they go about 150 feet. Okay, and it's in feet are my units. And the x scale doesn't matter, it's just what are our tick marks. I'm going to go in steps of 25. And my y, how high does a ball go? I don't know how high a ball goes, but I know it's not going to be a negative value, but maybe it goes up to 50, and we can go, say, in steps of 10 or something. But the x scale and the y scale aren't as important. So let's go ahead and go over to the calculator and put these into the calculator, and then we'll make our sketch. Okay, so here I'm in my calculator. I'm in parametric mode, and I put my x and my y into my calculator here. And we are going to have to adjust the window. You can see my window is here, so when I press window, you can see what I have, and they're the values that we talked about, going from 0 to 5 in steps of 0.1 and 0 to 150. You can see my graph that it is sketching it out. Now we're entering in 15 degrees, so in this example, since we're entering in a degree, when we go to our mode, we have to make sure we're in degree mode since we're entering in degrees. Okay, so again, we're in parametric and degree mode, and I went ahead and graphed it. So you can still see my window and what I typed into the calculator. Notice where I'm ending my parentheses. Okay, so what we're going to do is we're going to go ahead and sketch this on our paper. And looking at this, we can see since our Y scale is about 10, I can see that the ball went about 10 feet high. And then the ball went about, and these were in 25s along the X, 25, 50, 75, 125. A little less than 125 feet was our units. Okay, so we're going to look at about how far, and we're going to sketch it to see where it hit the ground, because at this point right here, it's when the height is 0. It's this x-axis here is the ground, so we can see how far it went and how high it went, and then we can track the time when it reached its maximum, the time when it hit the ground, so we can see how long it was in the air. And you can also see here, it's not starting at the origin, it's starting 3 feet up, because that was the initial height. So let's go back to the PowerPoint, and then we'll do our sketch. Okay, so I went ahead and did some of the sketch. So on our X and our Y axis, we should indicate the start value was at 3, and I have a circle indicating the start. The path it went was in this direction when we saw it was going this way, and then it hit the ground here, which was a little before 150, and the height was somewhere around 10. So this is the level of the sketch that I want to look at for now. For the next question, it says, how far does the ball travel? So to look at how far the ball travels, we want to see where it hits the ground. We want to look for that value. So that implies the x-coordinate, or the horizontal direction. So we want to find the x value on the graph, or the x-intercept. So how far is the x-intercept? And at the x-intercept, we know that the y-coordinate at any x-coordinate any x-intercept is 0, because this point right here is where it hit the ground. That's my x-coordinate. So I want to find the x value, and I know the y value is 0, because at any x-intercept, the y is 0. So if I plug in my y-coordinate as 0, I can algebraically find. So I'm going to plug in 0 into my y-coordinate. So my y equation, I'm going to plug in y equals 0, because originally it was y equals negative 16t squared plus 92 sine of 15 degrees t plus 3. Now this, when you just have one equation, this is just a standard algebra 1 quadratic equation, where this is my a value, this is my b value, and this is my c value. So when I want to solve this, it's a quadratic, and I can solve using the quadratic formula. So let's go ahead and plug in these values, a, b, and c, into the quadratic formula. Okay, so I wrote down the quadratic formula, and I plugged in my values of a, b, and c. And I have plus or minus. One of these is going to be a negative number, which would correspond to a negative time, which in the instance of hitting a ball, that doesn't make sense. We're going to choose the positive value that we get out from our calculator. Again, since we're plugging in 15 degrees, we need to be in our calculator in degree mode to get this answer of 1.605 seconds. So what this tells me is that the ball was in the air for 1.605 seconds until it hit the ground. So this isn't actually what we want to know yet. We want to know how far does the ball travel. So in order to see how far the ball travels, well, I know it took 1.605 seconds for the ball to hit the ground. That's when the y-coordinate was 0. So it took 1.605 seconds to hit here. Now I want to know how far it went, which was the x-coordinate when t equals 1.605. So I'm going to plug this in my t into my x equation. So I'm going to go ahead and do that now. My x equation is x equals 92 cosine of 15 degrees, and I'm going to multiply that by t. So I'm going to plug 1.605 in for t, and I get x is 92 cosine of 15 degrees, and I'm going to take that whole number and I'm going to multiply it by 1.605 seconds. And when I plug this into my calculator, again, still in degree mode, I'm going to get how far the ball went, which is 142.6 feet. So this is how far the ball went, which corresponds to in my graph, I remember they were in steps of 25 on my calculator, that it was less than 150, but kind of, around there, and this number is about that. So how far did the ball travel? The ball traveled 142.6 feet. Okay, let's go on, move on. Well, for this question, we're asking how long was the ball in the air? Well, we talked about that already. We had the ball, it started 3 feet above, it hit the ground. That point where it hit the ground was 142.6 feet. And how long was it in the air? Well, the time it took to get here was at t equals 1.605 seconds. So that's how long the ball was in the air. At 1.605 seconds, the ball is on the ground where the y-coordinate was 0, or the height of the ball was 0 because it hit the ground there. Okay, the next question says, what was the ball's position after a half of a second? So that's a time. So this is t equals 1/2. So we're going to plug t equals 1/2 into our x equation and our y equation, and then we'll get its position. We'll get its horizontal position, its x, and its y position, its vertical position, y. So we're going to plug t equals 1/2 into both of our equations. So let's go ahead and do that now. Okay, so I plugged in 1/2 for my t into my x equation, and when I get that out, I get 44.4. Sorry, that came out really messy here. 44.4 is the horizontal distance it's traveled in a half of a second, and when I plug this into my y, I get 10.9. So what that tells me is after a half of a second it went over 44.4 feet and it was up 10.9, and it's about here. And remember, the path of the ball looked like this, so it was somewhere over here was the position after a half of a second. And remember, it took 1.5 seconds to get there. So that is in the realm of reasonable for our answers. So we could say, what was the ball's position? After a half of a second, the ball was 44.4 feet horizontally away from the start and 10.9 feet off the ground. Okay, that is all we have for this. There are a few other options on how you can answer a couple of the previous questions. For example, in this section, after we found when t is 1.605, we plugged it into here to find that. You could put your calculator in regular algebra function mode and do calc value. Remember, if you press the button calc and then value, you can put in a value, and we can put in a t value of 1.605 and it'll spit out that answer. Alternatively, if we put this equation here instead of in parametric mode, but if we went back to function mode, and if we were in algebra class, we could graph this, which is a parabola, and this would be a parabola relating the height and some time. We could see when the height was 0. So we could, if we were in function mode here, we could graph it in our calculator and do calc 0. And when we do calc 0, what that was doing, it was looking for this and looking for the x-intercepts here of it. And if we did calc 0 of that graph, it would find the, remember this is our t, because this is our variable t and our y, it would find the time that it took for y to be 0. So if you do this in function mode, you'd get out 1.605. So there are alternative ways using our algebra skills to get these values and avoid the quadratic formula, but you have to switch out of parametric mode and into function mode and graph that on your calculator. So there's a couple alternatives there you have. So that is all for tonight. I hope you have a wonderful evening.